A diode is a device which is used to convert alternative current into pulsating direct current. Diode has many applications, but one of the most common is in power supplies as a rectifier. Two types of rectifiers. 1 half-wave rectifier, 2 full-wave rectifier. Half-wave rectifier. AC sources connected to a load resistor throughout diode during one cycle of the input voltage when the sine wave input voltage goes positive. The diode is forward biased and conducts current to the load resistor. The current produces a voltage across the load which has the same shape as a positive half cycle of the input voltage when the input voltage goes negative during the second half of its cycle. The diode is reversed biased, there is no current to flow. So the voltage across the load resistor is 0. The net result is that only the positive half cycle of the alternating current, AC, input voltage appears across the load, making the output a pulsating direct current, DC, voltage. This process is called half-wave rectifier. Average value of half-wave output. The average value is the value that would be indicated by a DC voltmeter. It can be calculated with the following equation where VAV equals a VP Greek letter pi equals 3.14. The above picture half-wave voltage with its average value has been indicated by the dashed line. Example, what is the average DC value of the half-wave rectified voltage waveform? Solution. Formula equals VAV equals a VP.
Π ίσον 3142 ίσον 103, 142 ίσον.
31.83 The effect of barrier potential on half-wave rectifier output. During the positive half cycle, the input voltage must overcome the barrier potential before the diode becomes forward biased. For silicon diode, this results in a half-wave output with a peak value that is 0.7 V less than the peak value of the input. The expression for peak output voltage is Pout equals Vpin minus 0.7 V. Determine the peak output voltage of the silicon rectifier circuit for the indicated input voltage solution. Formula of Pout equals Vpin minus 0.7 V. So, the peak half-wave output voltage VP equals 5 V. 0.7 V equals 4.3 V. Peak inverse voltage, PIV. The maximum value of reverse voltage, sometimes designed as peak inverse voltage, PIV, occurs at the peak of the negative alternation of the input cycle when the diode is reverse biased. Full-wave rectifier. The difference between full-wave and half-wave rectification is that unidirectional current to the load during the entire input cycle, and the half-wave rectifier allows this only during one half of the cycle. The result of full-wave rectification is a DC output voltage that pulsating every half cycle of the input. The average value for a full-wave rectified voltage is twice that of the half-wave, expressed as follow.
V average equal to peak voltage upon pi. Example, find the average value of the full wave rectified voltage. Solution. Formula V average equal to peak voltage upon pi, and pi equal to 3.142. So the peak voltage is 15, and then 2 multiply with 15 upon pi equal to 9.55.
One center tap full wave rectifier. This type of full wave rectifier circuit uses two diodes connected to the secondary of a center tap transformer. The input signal is coupled through the transformer to the secondary. Half of the secondary voltage appears between the center tap and each end of the secondary winding. For the positive half cycle of the input voltage, the polarities of the secondary voltages as shown in above figure. In this condition, forward bias the upper diode D1 and reverse bias the lower diode D2. The current path through D1 and the load resistor, as indicated, for a negative half cycle of the input voltage. The voltage polarities on the secondary as shown above figure. In this condition, reverse bias upper diode D1 and lower diode D2 forward bias. The current path is through D2 and the load resistor is indicated. Because the current during both the positive and negative portion of the input cycle is in the same direction through the load, the output voltage developed across the load is a full wave rectified DC voltage. Peak inverse voltage, PIV. Each diode in the full wave rectifier is alternately forward biased and then reverse biased. The maximum reverse voltage that each diode must withstand is the peak value of the total secondary voltage versus. When the total secondary voltage versus has the polarity as shown in above figure, anode of D1 is plus V/2 and the anode of diode D2 is V/2. Since D1 is forward biased, its cathode is at the same time voltage as its anode, negative the barrier potential. This is also the voltage on the cathode of D2. The total reverse voltage across D2 therefore is plus V/2. V/2 equals V/2 plus V/2 equals versus full wave bridge rectifier. The full wave bridge rectifier uses for diode 1. The input cycle is positive, then diode D1 and diode D-. 2 are forward biased and conduct current in the direction shown. A voltage in developed across RL which looks like the positive half of the input cycle. During this time, diode D3 and D4 are reverse biased. When the input cycle is negative, then diode D3 and diode D4 are forward biased and conduct current in the same direction through RL as during the positive half cycle. During the negative half cycle, diode D1 and diode D2 are reverse biased. A full wave rectified output voltage appears across RL as a result of this action. Bridge output voltage. During the positive half cycle of the secondary voltage, diode D1 and diode D2 are forward biased, neglecting the diode drops. The total secondary voltage versus appears across the load resistor. The same is true when diode D3 and diode D4 are forward biased during the negative half cycle. Thus, VOUT equals V's. Two diodes are always in series with the load resistor during both the positive and the negative half cycles. If these diode drops are taken into account, the output voltage silicon diodes equals 0.7 plus 0.7 equals 1.4 is VOUT equals V's 1.4 V. Peak inverse voltage, PIV. Assuming that diode D1 and diode D2 are forward biased, let's examine the reverse voltage across diode D3 and diode D4. Visualizing diode D1 and diode D2 as short. Ideally, diode D3 and diode D4 have a peak inverse voltage equal to the peak secondary voltage. Since the output voltage is ideally equal to the secondary voltage, then PIV equals VOUT. The PIV rating of the bridge diodes are half that required for the center tapped configuration.